Okay, good morning. Welcome to our talk on quantitative research. My name is Karuthan Chinda from School of Medicine, Serious University. Okay, this is the content of today's our discussion on what is the research area of interest until study design. As a student in doing research, you must understand each and every one of these areas. So what is research? According to the definition given by Merriam-Webster, so it talks about examination, specifically investigating or experimenting, discovery, interpretation of facts, revision of concepts or theories, new facts, practical applications of such new revised theories or laws. Research is ongoing worldwide. Billions of dollars are spent every year to discover, interpret, and all the things that comes under this definition. All right, some selected researchers. So these are some of the examples, okay? Examples, some of the researchers undertaken by students or researchers. So where do you start? Where do we start? Doesn't matter you're a student, you're a researcher. Where do we start? That's a common question. So where do we start? Choose an area of interest. That area of interest must be, you must be really interested in that area. Example, the previous type of research we talked about. We talk about dengue, right? Your area of interest could be dengue, right? Another person's area of interest could be vaccination, awareness, acceptance of vaccination. Another person can be a new drug for the treatment of diabetes. So area of interest is diabetes, right? Next, take a piece of paper and draw a neat circle. That's where we start our research, right? Draw a circle. Next, write your area of interest inside the circle. Don't write a sentence or paragraph, maximum 2 words. If you're interested in dengue, just write dengue. Your interest is dialysis patient, just put dialysis, right? So 2 words. Area of interest. And beside the circle, write the definition of the area of interest. If your area of interest is dengue, write there, what is definition of dengue? Don't assume that everybody knows what's dengue. You define it, right? Your definition is diabetes, and you define it. What is diabetes? Don't assume people understand whatever area you're talking about and the definition that's come after. You define it according to your research, right? Sometimes what you do, take the area of interest, go to Google, just type the area of interest, example, dengue, definition, will come out. Depression, definition, so definition will come out. So make sure you understand what exactly area of interest and how it is defined in your area of research. Different researchers could be defined differently, right? So then write, talk, discuss, sleep. Make sure I talk to others about the area of interest. Then your understanding gets better and better. Our example today, we're going to talk about area of interest, depression. So I go to Google and search what is depression. According to APA, depression is a common and serious medical illness. Serious medical illness that negatively affects how you feel, how you think, how you act. So these are keywords in that definition. Later, I want to capture the level of depression, measure the level of depression. I must expand my instrument to measure how the person feels, thinks, and acts according to this definition. That's why it's very, very important. This is my area of interest. That is your definition according to some valid authorities. Next, you already decided your area of interest. So what's next? Indicate which target population you want to study. Which population you want to study. Example, dengue. You're talking about KAP, which population? It can be general population, can be nurses, it can be university students, can be teachers, right? Define it. In our example, how do you define what is depression? My population of interest is dialysis patient. Depression can be in any group of people, but I'm taking it specifically among dialysis patients. So my title evolved from here. So what is it now? Depression among dialysis patients or patient undergoing hemodialysis, right? Don't start with the title. Start with the area of interest. Then choose the target population. So your title evolves naturally from these two. Okay. Symptoms. Again, we talk about depression. So what are symptoms? So these are the common symptoms. Right? Feeling, having depressed mood, all this. So how are you going to measure the level of depression later? So you must have something to measure that particular concept of depression. So these are some of the questions maybe you ask the respondent how he or she feels to assess the level of depression. Area of interest, population in selected studies. Just now, I mentioned some selected researchers. So what are the area of interest here? Dengue, bacteria, all these marked in red are areas of interest. What's the population? So all those marked in blue are the population. So what's glaring is dengue, Taylor's undergraduate students. Dengue in this population. But what do you want to know? You want to know KAP. So you must make sure that those marked in red, that's the area of interest. Those marked in blue, that is your population of interest. Some preliminary data gathering, once you decide that this is my area of research. So what do? Take the area of interest in mind, observe, interview, or some readings. To fortify this area of interest really need to be studied a lot, right? In our example, may include, that's why my depression is my area of interest. I do some observations of the patients. Maybe I go to dialysis centers, observe the patients, or I can interview the patients or the caregivers or the staff members to get more insight about what I'm talking about in the target population and some literature, some articles or reports, right? Whichever you come across, read. So when you do the 1, 2, and 3, this particular, whatever area you choose, right, the more insight you gain. One such article is Depression Among Dialysis Patients Attending Tertiary Hospital in Kerala, right? So Journal Nephrology, so volume 40, quite recent, 2016. So a lot can be guided based on this particular whatever content they have, right? So there are not only one, you go and search more. The more you search, better understanding you get about this, whatever express, whatever the area of interest you have. Next, problem statement. After going through all that, so what's the problem? Right? What is the problem? Example, dengue, KAP, cholesterol. So what's the problem? So the problem statement, normally we write in terms of 4 wives and 1 husband. 4 wives are what, why, where, and who. And last one, how you're going to do the research. So problem statement, the first two, what and why, are very, very important. If you're a researcher, you must tell us exactly why, what is this, and why is it important. These two are global. Example, what is depression? The definition already there. How the person feels, thinks, and acts, this kind of thing. So why is it important? What if the guy is depressed? Right? What are the consequences? Consequences, it could lead to suicidal ideation, right? May not be conformance to particular treatment, be burden to the caregivers. So what are they? Why is this important in a particular area of study? Next, where the study to be conducted. So these two are global. Now going specific. Okay, where the study will be conducted. Say in Malaysia. In Malaysia, who? Right? Which group of people? Dialysis patients. The whole thing can be depression, and why it's important generally. Come specifically where in Malaysia, who you can be very specific among college students, among dialysis patients, among nurses, very specifically which group you're talking about, and state the study design, how the study will be conducted. So you must tell the reader how the study will be or has been conducted. This is testing the validity of your design. If design is not valid, whatever finding you have, useless. Right? So research objective and research questions. So from there, what's my general objective? The area of interest followed by whatever causes or consequences. Sometimes we say factors associated. Example, KAP in dengue and the factors associated. Depression among dialysis patients and the factors associated. So from there, you write the specific objective. It can be several. I just given 3. Determine the prevalence or level of the area of interest. Example, knowledge of dengue among college students. To identify the factors associated with this. Some students they know more about dengue, some are not. So what is the factors? What are the factors associated? And what are the consequences? Right? So research objective clearly state that particular area of interest and what you want to know, therefore the causes and consequences. So break it up into several. It's not necessarily must go 20, 30 objectives. 3 objectives are fine. Some want to write the research question. Just turn the objective into research question. You can modify slightly. Here to determine the level, here question is, what is the level? Here, determine the factors. What are the factors? Determine the consequences. What are the consequences? Of course, you can more, because 3 objective, you can have more than 3 questions here and modify the question you want to. All right? So in our objective, in our example, so that's my general objective. Determine the prevalence of depression. That's my area of interest. Among whom? Among patients undergoing dialysis. Then what do you want to know? What are the factors associated? We'll break it up into specific objectives. First objective can be determine the prevalence of depression. Right? Example, 30%, 40%, or the patients are depressed. That kind of thing, answers I want. Determine the factors associated. Why some are more depressed, some are less? What factors associated? Is it the age? Is it the disease severity? We don't know. You want to expect, you're going to find out this. Just this, measuring this alone, 40% of the dialysis patients are depressed. That's not enough. Why some are depressed, some are not? Who are the 40%? Who are the 60%? What are the factors associated? We need to know this. And what if they're depressed? 40% depressed, so what? What are the consequences? Right? So these are the 3 specific objectives we are taking for this particular research. You want to turn to the research question. As I mentioned just now, just turn them into questions. You can modify it slightly, whatever it is. Some researchers write only the objective. Some researchers only write research question. Some write both. Right? Depends on situation. Okay, where's next? So I already know what I want to know. Objective is what do you want to know? So next, where do I go? Whom do I turn to? Literature review. Right. So what's the purpose of literature review? What does it do? Assessing knowledge. Let's say you're new to the research, but you know where to go. Go read the literature. What are the assisting knowledge in this particular area? So this prevents reinventing the wheel. Don't start all over again. People have done many, many times. We follow something similar. Right? Shapes your research. Gives ideas from what people have done, something you haven't thought of. That particular article tells you, we did this way. That means sparks useful insights. And give ideas of what variables to consider. Among factors associated among the depression, factors associated with depression among dialysis patients. So what factors, what to consider? Again, fall back in literature. And terminologies, definition of concepts, right? We know easily what the definition of the concept depression in this particular situation. Study design, that is quantitative or qualitative. Let's say 10 studies went through, or 10, 9 did qualitative study. So this talks on quantitative study, qualitative study. Then you have to follow qualitative. Out of 10 studies, 9 studies did quantitative. Then justify that you can do quantitative. But suppose out of 10 studies, 5 did quantitative, 5 did qualitative, most likely you have to do the study design, not solely quantitative, qualitative, or mixed design. All right, that's what we're going to do. This last one is very important. Tools to be used. In social science researchers, the tools, we call them questionnaire. What question to ask? Example, depression. There are so many questions available. We don't have to reinvent, start all over, design a questionnaire. No need. There are so many questions available. Some are free, some you have to pay. And see which tool is very, very appropriate for your study. And then just use it, adopt it, or adapt from many studies. Right? So that is why literature is important. Right? Where to search? Whatever website, reports, all this. But since ours is academic research, make sure you search journals. Right? So where do you search? These are some of the search engines which are free. Right? Just an article, like a Scholar, most likely get it free, or Medscape, PubMed, other things. So we know which platform to go and search. Just put a keyword and search. You get more ideas, right? More researchers would have published some articles. You get better idea on the area of research. Literature review. What's the power of the literature review? Let's say you have 10 articles already, right? Example, let's say we have depression on dialysis patient. We went through 10 articles. Each article may be written average of 3 authors. That means 10 times 3, you get 30 supervisors there waiting for you. So input from 30 minds in a research. All the 30 people could have thought differently or similarly, it doesn't matter. So you get an idea. What's the general trend? What people are talking about? The articles must be recent and relevant. Don't take an article that's written in the year 1990. But the pioneer is very important, yes. But things evolve over the time. So say take some recent articles. Let's say 2015, 16, 2020, and must be relevant to your work, right? People could have talked about depression. They never talked about dialysis patients. So relevant, okay? Okay, literature review in our example. Our example is depression among dialysis patients. Some of the variables identified could include age, gender, education, of course, religion, right? Another set of variables can be like disease duration, hospitalization, frailty, this kind of thing. Another set would be perceived family support, right? And social support. So these are the demographic characteristics of the patients. These are concerning the disease itself, duration, whether hospitalized and other things. So these are external factors. So asking factors associated, there can be internal factors, demographic characteristics. There can be disease-specific characteristics, or can be external factors. The more you search, the more information you gain, the stronger become your proposal. Right, research design. Research design broadly classified into 3 main areas: quantitative, qualitative, or mixed method. Right? So, of course, this particular talk is on quantitative research, but briefly let's go through other two as well. You must have a knowledge of what's other two, so that when you read literature, we know what they are talking about. Right, quantitative research is based on measurements of quantity, okay, numbers, set of numbers, right? Some of the characteristics, numerical. Example, you want to measure obesity of your respondents. We take the height, we take the weight, and use a formula. Numerically, we can say that's a BMI. It's not descriptive. Apply statistics and use numbers. Right? We compute BMI. So BMI 30, BMI 20, BMI 25, all are numbers. Let us interpret the numbers. It's an interactive process whereby evidence is evaluated from the numbers, often presented in terms of tables and graphs. Right? Table, we can say demographically the patient's gender or age, ethnicity. We can say what's the BMI, the average BMI for each characteristics and graphs. It is conclusive because we take objectively the weight and the height we measure. All are mostly machines or tools are measuring, so it's quite conclusive. There's no bias goes in here, right? Interviewer bias won't be there because the machine measures your weight, your tape measures your height, right? Minimal bias. Investigate what, where, and when of your decision making. Like what is the level of obesity, where, which group of people, when, at which stage of life, right? Quantitative, on the other hand, is concerned with qualitative phenomenon involving quality. Some of the characteristics, they're not numerical, but descriptive. You can ask more detail. If we say, I do not support the idea, we can ask them, why do you say so? Applies reasoning, uses words, right? Aim is to get meaning, feeling, and description of the situation, describing the situation. The person say no, you ask them why exactly are saying no. So you can handle more detail why the person says so and other things. Qualitative data cannot be graphed. Exploratory, meaning deep down you go and investigate why, and the how, right? So that's a basic difference between quantitative and qualitative. But now, this method is gaining more popularity. Instead of relying on one method, why not we marry the two? So mixed method includes mixing quantitative and qualitative. The data, methodology, paradigms, they differ between the two, qualitative and quantitative. So by mixing this, instead of mono method, either quanti or quali, now research can be improved through use of multi-method. So methodological pluralism, right? So that's a current trend is moving. So this session will discuss only on quantitative research. Okay, what's variables and frameworks? Variables and framework. So what's a variable? Variable is a characteristic interest that takes different values, different items or objects. Example, height is a variable. Why? It varies from person to person. Weight is a variable. Varies from person to person. Level of knowledge is a variable. Level of depression is a variable that differ from person to person, right? So in your research, you must know specifically what variables you're taking and how you're going to measure it later, right? What do you measure and how do you measure is very important. We can't measure a variable, then it's useless. Opposite a variable is constant, right? Example, number of heads per person, only one is a constant. We don't study them, right? So variables are central focus of statistics. So we must consider this in your particular area of research. That's very important. So in our case now, remember our objective is determine the prevalence of depression among patients and the factors associated. Just now we mentioned based on our literature, these are variables we found initially. So our outcome variable of interest is depression, level of depression. How do you measure it? Maybe a questionnaire, right? What do you want to measure and how do you measure it? Other demographics, let's say age and religion, disease characteristics, and also the external factors. There can be more. Of course, there are much more than this. right? For our discussion, we took only this number of variables. So age differ from person to person, religion differ by person to person, dialysis duration, some can be very long, some can be short, perceived family support against a perception, but still that perception varies from person to person. Two people can be in the same situation, same family and social group, but they may perceive the support they receive differently, right? So types of variables. So variables can be quantitative or qualitative. Variables can be quantitative or qualitative, right? So examples are like blood pressure. Blood pressure 120, let's say 122, 128. So these figures can be averaged. So basic difference or comparison between quantity and quality is that values of quantitative variables can be averaged, but values of qualitative variables cannot be averaged. Example, to find average, we add these values and divide. But here, yes or no, yes plus no become what? They're not additive. So whatever variables, the values of the variables cannot be added, divided, whatever it is, they fall under qualitative. Here, HbA1c, all these measurements can be averaged. Sugar control, right? Once you define it good or poor, example, more than 7 is poor, less than 7 is good, then you can't average them. Same thing, exam marks, all this can be averaged. But grades, once you grade them, grade A, B, C, D, you can't average them. Number of road accidents, how many accidents per day, we can average it over the time. But the vehicle that is involved in the accident, whether car, motorbike, or bus, they can't be averaged. So very careful of what variables you have and whether how they measured quantitatively or qualitatively. Later, when expressing this variable, describing them, here we use more mean, standard deviation, median, that kind of things. But here, we talk about more of a frequencies and percentages, right? So this is very important. The beginning itself, when you start your research, identify the variables and see how they're measured. Data. Data is a raw material for analysis. This data may come from primary source or secondary source. Primary source, one collected by the researcher himself or herself. Secondary source obtained from other sources. Some examples here: surveys, experiments, observations, interviews. Over the site, reports, journals, company reports, data depository, right? You take the data from some sources, right? So data, both are useful. I'm not telling one is more important than the other. Of course, the advantages and disadvantages, but both are useful to get your whatever evidence you're looking for. So types of data, again, can be quantitative or qualitative. The quantitative data further can be subdivided into continuous or discrete. Qualitative data into nominal or ordinal. Example, marks in exam. Distance travel. Like distance travel, mostly we have decimals. So they are continuous variables. Discrete variables include numbers which are integers. Number of students set per exam. We don't have 10.3 students. Number of accidents, right? Number of accidents, 5, 10, 15. We don't have fractions, right? So that differentiates continuous and discrete. Under qualitative, it can be nominal or can be, sorry, it's a mistake here. It should be ordinal, okay, ordinal. So nominal, names given, like blood group A, B, AB. It doesn't mean one is superior to the other, right? These are just names given to whatever combinations we have. So blood group, there's no order. On the other side, this, remember, ordinal, order is very important, right? For grades, exam grades, let's say A, B, C, D. So grades, right? Grades are ordinal. A is better than B. B is better than C. The same alphabet given here, blood group A, B, does not mean that A is superior to B. But grades, the same alphabet used for grades, A is better than B. So remember, these variables cannot be averaged values. This we can do average. Why do we talk so much about this? Because later, when you do the analysis, depends how your variables are measured. They all follow different distributions, right? Okay. Conceptualization. Okay, conceptualize. In our example, our objective is to determine the prevalence of depression among the patients undergoing dialysis and the factors associated, right? So now, as we pointed out just now, we have these variables from literature. There's my outcome of interest. These are the characteristics of the patient. These are the disease pattern and the support. And we can put them into respective concepts, right? So this box here, all these are the patient's demographics. Here we have the external factors as perceived. These are perceptions. These have the disease, duration, and other things. Here we have the outcome, and central focus is depression. So now we can name these concepts. Instead of naming each variable age, gender, education, so they fall under demographic characteristics. Instead of describing one by one, we can say these are disease characteristics, right, that consist about these particular variables here. External factors, how he perceive or she perceive the environmental factors, family support, social support, other things. And then the outcomes. So now I can say they are conceptualized, right? Our central focus is depression. So once you conceptualized, next is getting a conceptual framework. A framework is how the concepts are interconnected. Framework, right? So my central focus, depression, and this side I have the demographic characteristics. How are they connected? Are these two connected, right? If yes, example, older the person, higher the depression, right? Better, a religious person may not be as depressed compared to a religious person. If we have all these evidences in literature, now you can see that these factors, which are demographic characteristics, may have an impact on depression. The other concept, disease duration. The longer duration, more hospitalization, more comorbids, they may lead to higher level of depression. Another concept, the external factors, how he or she perceives, that may lead to depression. Remember the same situation, two people there, they may perceive the support received differently, right? So this is only perception. So once you have this down, so what does it lead to? Okay, lead to the outcomes of non-compliance for disease management and suicidation. Suppose it does not lead from here to here, I'll say, so what? Because of this come to play. That's where the problem starts. So that's a conceptual framework. We talk about all the concepts, conceptualize what they are, right? Demographic, their disease, external factors, depression itself is a concept, you define it, and this concept, the outcome. So when you put it this way, you know exactly what you're looking for in your research. Remember, our central focus is depression, prevalence of depression, and what are the factors associated with that, causes, and what are the consequences. So whatever we talk about, the whole thing can be pictured in a framework. This is very, very useful, right? You can talk, show this to other people, and show this to your supervisor, right? This is what I got. How do you know this connects? We can't simply connect it, okay? There must be theoretical base to this. That's why literature comes in. right? So within few hours, my central focus depression, factors associated, and the outcomes. By go through sufficient number of journal articles, I can have all this information, right? So now we have a framework. We can show to others, some expert in the area, or your supervisors, and see whether any other concepts are not included in the framework, right? What other concepts may lead to this? So we don't know. You go and search literature, or a person expert in this area, he or she may know some other variables had not been included, so bring the variable in, right? So we do literature as well as consult with specialists, experts in this area. All right, so this even looks neater. All these lead to depression, and that may lead to non-compliance disease management. So this particular diagram looks neater than the previous one. All right? Okay. Hypothesis. So what is hypothesis? Hypothesis is a tentative yet testable statement. Tentative, the proposal hypothesis, tentative. It may be true, maybe not. Yet testable. That means collect data, analyze it, and see whether what is said is true or not. Testable statement. If it is not testable, meaning you can't collect data on it, analyze it, then it's not a hypothesis. So tentative yet testable statement predicts what you expect to find. What you expect to find. Example, let's say, right? Age and depression. Your hypothesis may be the older the person, higher the level of depression. How do you measure it? Testable? Yes. I can take the age, I can measure the depression using a questionnaire and do some statistical analysis and see whether age can be used to predict depression or not using empirical data. So in your research, there could be several hypotheses, right? So we say it can be several like H1, H2, H3, and so on, right? So the process is form the hypothesis, Example, there's a relationship between age and depression, or the older the person, the higher the level of depression. Hypothesis, collect data. So in this case, I need to know the person's age and his level of depression. Level of depression, measure using a questionnaire, and then test it. So what test do we use here? All this you must know in the beginning of your research itself. How do you know what that test we used? That's where literature comes in. So I want to compare age and, let's say, depression. What test we used? All these will get the enough information from literature. Right, hypothesis, there are two types. One can be directional, other one non-directional. Directional and non-directional hypothesis. So what's the difference? Directional hypothesis, there will be words like positive, negative, more than, less than, and so on. So these keywords will be there, right? So look at the example here. There is a positive relationship between motivation and performance. Positive. That means as the motivation increases, performance increases. Directional. So you want high level of performance, you must have high level of motivation. When the workers are motivated high enough, their performance will increase. Okay, that's what this hypothesis tells us. Next one, income and expenditure. When the income goes up, the expenditure also goes up. The reason behind, when income increases, your surplus income, right, increases too. So that could be invested or spent on some other things, right? The reason behind it, right? Women workers are more motivated, right? They're comparing women and men, right? So comparing, the word here is more. So these are keywords found in this hypothesis. They are directional, so you call it directional hypothesis. The non-directional hypothesis, look at the example here. There is a relationship. I didn't say positive or negative, right? There is a relationship. I still don't know which direction does it go. There is a relationship between income and expenditure. Again, I don't know how it works. There is a difference. I didn't say females higher than males. That's a difference. That means one gender, higher level of motivation compared to other. That's all I know, right? So now, which one to use, directional or non-directional? That will be guided by the literature, right? That will be guided by the literature. Let's say you wrote that there is a relationship between motivation and performance. You didn't say any direction. I go through some of the journal articles. All are telling is a positive, positive, positive. I mean, you missed out something. So whether directional or non-directional must be guided by the literature. Right. Study designs. That's very important. So how the study will be conducted. Right. Data collected, we analyze wrongly, we can reanalyze. The study design goes wrong, everything goes out. That means your research won't be valid. So pay sufficient attention to these study designs, because that's where how the data will be collected. If this study design is not a proper design for your study, then whatever data you collect, however analysis, whichever expert statistician analyze the data, whole thing is useless. Right? All right, so we're going to go through several study designs and see in what situation we're going to use which particular design. Okay, number one is cross-sectional, or call it snapshot. Right? Most questionnaire or data sheet, right? We collect patients' information. So all these are cross-sectional at that time point. At that time point, when I meet the person, what is age, gender, what is occupation, height, weight, so cross-sectional at that time, right? So most of the time, surveys use this kind of a study design, right? From here, of course, it can create a lot of objectives based on objective. Example, that we have BP, SBP, DBP. From here, the measurements, we can decide whether the person's hypertensive, yes or no. And what are the factors associated with hypertension, right? There will be several objectives for us to collect this particular data. So it's cross-sectional. Next, cohort or prospective. Cohort meaning marching forward, marching forward. Prospective, okay, marching forward. So we have a population, condition-free subjects, right? Whatever condition I'm talking about. Expose one group, other group unexposed. And in our time period, we follow them over the time. It can be 6 months, can be 1 year, can be 2 years, whatever. And then let's see how many develop the condition. Example, newly appointed workers at a cement manufacturing company. Some could be working in the plant who are exposed to the dust pollution. Some could be working at the offices who are not exposed to the dust, right? So we don't force them, you work in the plant or you work in the office. Based on your whatever intake, some have to work in the exposed area, some are working in the unexposed area. Supposing these people were recruited at the same time, let's say January of the month of the year. Any follow-up, let's say 6 months. 6 months, develop condition. What condition talking about? Exposed to dust. There could be some lung ailment, right? So have they developed the condition, right? Or continuous coughing, whatever it is. So the A is number, exposed and developed condition. B, also exposed but did not develop the condition. Also the same situation, this person develops some lung problems, this number did not. Right? Same thing C, unexposed but develop a similar condition for whatever reason. D unexposed and did not have a condition. So data is captured in terms of numbers, right? So what do you want to know? Question, what percentage exposed develop the condition, right? Let's say now we have 100 people here exposed, working the plant. Out of 100, 70 have the condition, right? Lung ailment. Let's say now we say 70% of the exposed have developed the problem. Of course, here also some people may develop, right? Let's say another 100 workers here, only 10 develop the condition. That means it's not due to the exposure, some other reasons. Then 10% of the unexposed have the condition. And from here, we can do a lot of analysis. About 20 different analyses can be done with the data captured in this table form, right? So that's prospective going forward, moving forward, right? Case control. Case control, retrospective. Retros moving backward, moving backward. So here present time, you go backward and see what happened the last time. Trace back, right? Example, cases lung. So here we want to know what is the exposure smoke. Is it a risk factor for lung cancer? So what do? From the population, we select number of subjects, some with condition. Here condition referred to lung cancer. We select people without lung cancer. Of course, we also do some controlling for the matching for the age, gender, and other things, or even occupation, right? With condition, cancer, no condition, no cancer, control, and go back and find out whether exposed or not. So in this case, the exposure is smoking. This unexposed, not smoking. So each one of these cases here could have been exposed or not. Same thing here. Could have been exposed or not, right? And back to the same table we capture. So what is A? A is those, example, we follow this example, the cancer patient who smoked. So what is B? Cancer patients who did not smoke. That's a B. So what is C? C is controls, no cancer, but they smoked, right? And so on. So now you are going backward and see whether the outcome of interest, lung cancer, is it associated with smoking, or simply is smoking a risk factor for cancer, right? See, the objectives are very important. You follow the objectives and decide what kind of study design you could have, right? Again, the question is, what percent of those with the condition were exposed? What percent of those with the condition, lung cancer, were smokers? What percentage of those without lung cancer were smokers? And comparison will be made. Again, there are so many tests can be done to confirm this. Right? Comparison of these two now, we talk about cohort, case control. So cohort, how does it work? Marching forward. Right? Case control, backward tracing. Right? So case control study. Right? Randomized control trials. How does it differ? Randomized, whatever subjects will be randomized into two groups. Control, the two groups, one will be treatment group, one will be control group. So it's called randomized, here's randomized. Earlier, we did not do randomization, right? Naturally, the person working in the plant or working in the office. A person have cancer or no cancer, no randomization. So this is one of the research design that's very useful to find the evidence of particular exposure, whatever it's drug, right? So randomize them. That's an example. Effect of new herbal product on blood sugar among diabetic patients. So the population will be all diabetic patients. We select number of them, assess baseline, the mean BP, mean sugar level at baseline. So one group goes into treatment, other group goes into control. Sometimes call it placebo. So this is a baseline assessment. That's here. Then we put them on the treatment of placebo. After a certain time, let's say after 1 month, we assess them. That will be the X-bar CT and X-bar EC. Right? This is another study. Then what do you do? Basically, you're going to compare the difference from here to here. Right? The difference in the treatment group and the difference in the control group. The changes in the treatment group is significantly different from the control group. If yes, we conclude the drug is effective. Right? Example, let's say HbA1c, the treatment group, a drop of, let's say, 1 point. In the control group, drop of 0.1. So 1 point and 0.1. We tested statistically. We found to be significantly different. Then we say the drug is effective. Okay, that's randomized control trial. The evidence from randomized control trial is one of the highest. All right. Next, randomized crossover design. Right? Randomized crossover. So what's the difference? Same thing like patients here, or whatever subjects here, randomized. There are two groups. Until here, it's like RCT. Until here, like RCT. So what's crossover? After the first phase of the study, we cross over the A group to placebo, the B group, which was on placebo, into drug. So now, RCT subject in the control differ from treatment. If I stop here, it's RCT. This is a treatment, this is a control. Whereas crossover trial, he or she become control onto himself or herself. Same thing here. Right? So that's the advantages of RCT. But there must be washout period, we say. Right? Example, palm oil and cholesterol. People say palm oil is very harmful, increases cholesterol level, TCH. Right? So what do? We take subjects here, baseline, we measure the cholesterol level, randomize them, some into the palm oil, we give the oil to use, other group, the usual oil, whatever they're using. And after, let's say, 4 weeks, we assess what are the changes in cholesterol level and wash out. Ask them to go back to the normal, whatever oil they're using. So effect of palm oil be washed out. Then put them into, again, across it, into placebo. This become drug. And assess again. It's very interesting because the effect of the palm oil on cholesterol is controlled within oneself. The only thing is, some of the treatment the effects may not be washable. Right? Cholesterol, let's say after 4 weeks, more or less you go back to what you had in the earlier baseline values. Right? So evidence from this kind of study is even better. Okay? Longitudinal studies. Longitudinal sometimes can be just 2 points, baseline, another measure, and compare the values from here and here. Compare the values. Example, we take only diabetic patient, let's say, only diabetic, there's no control, baseline measure, and after treatment, and conclude whether there's the effectiveness of drug or not. We can also go further. Instead of 2 time points, many study time points, endpoint until the endpoint. More than 2 time points. We call it repeated measures. Longitudinal study, many time points. Example, we can talk about the growth pattern among children, right? Let's say after 1 year, we follow them, 2 years, 3 years, and so on. Sometimes we follow the adolescents, 12 years, and then 13 years, 14 years, we follow them. It's a longitudinal study. Many studies are going on in this area. Longitudinal with control. Just now we only one arm, just one arm only. So now you may compare 2 groups. Example, urban, rural kids. Right? The growth pattern, same thing, among urban and rural kids. So you follow the time. Let's say now this is 1 year, right? 2 years, and so on. Or adolescents, 12 years, 13 years, and so on. But we have comparison between 2 groups, urban and rural. It can be treatment or control. Right? All right. That's all for today. Exercise. Let's see what are the appropriate study designs for the following. Example, eating betel leaves is a risk factor for mouth cancer. So what kind of design will you have? Is it going to be case control, retrospective? We take a group of people mouth cancer, another group without mouth cancer, go back in time whether exposed to betel eating. Right? It is said that consuming palm oil increases cholesterol, as we just discussed just now. It can be crossover trial. 4 weeks on palm oil, right? Other group, normal oil. After 4 weeks, measure their cholesterol level and give a washout period and then cross it, right? Young cancer patients are more depressed. It's going to be population-based study, questionnaire. So this will be snapshot, cross-sectional. Obesity is urban problem. So again, we're going to take 2 groups, cross-sectionally. Teachers are more stressed, again cross-sectional. Children overweight tend to be obese when they are adults. So we'll follow the children until they become adults. It can be a longitudinal study. Papaya leaf is a remedy for dengue fever. Right? I know still people say it's not effective. Let's say you want to study this. So there'll be 2 arms. Right? It can be randomized control trial. Randomized control trial if the ethics committee approves it. Right? Long COVID. They are serious among patients with category 4-5 infection. Long COVID. We're going to follow them up after 1 month, 3 months, 6 months, 1 year, and how they fare over the time. Longitudinal study. Cervical cancer among women and the associated factors. Right? Again, case control. We take some women with cervical cancer. We match them with others, matched by age, whatever it is, who don't have the cancer, and see what are the exposures. This is ivermectin for COVID-19. Right? How long does it take to test this? Is it prospective? We're going to give many times or just 1 time? That depends. So what are the examples here? You have to choose a study design that is most appropriate for your study. The study design is out, the data collected is not valid. So whatever conclusion you're going to make later, all not valid. So pay attention, to the design. That's very, very important. Okay, with that, thank you. Wish you all the best.